So this past class, we talked about the concept of a mole and what is a mole. And it's important to remember that two things a mole is equal to are x grams on the periodic table. So for instance, 1 mole of nickel would be 58.69 grams, and 1 mole of copper would be about 63.55 grams. Know that these average atomic masses we see on the periodic table are always equal to 1 mole. Now, the second thing a mole is equal to is 6.022, and I usually limit it to 6.02, times 10 to the 23rd power particles. And these particles, for chemistry's sake, are going to be atoms or molecules, most likely. Now, let's look at problem number 1 here. The molecular formula of aspirin, one of the most commonly used pain relievers, is C9H8O4. So for part A, calculate the molar mass of aspirin. Now, how we do that again is we multiply the atoms or ions in the compound or formula unit by the individual molar mass of that element. So I'm going to do 9 times 12.02, and 12.02 again is just the molar mass of carbon, plus 8 times 1.01, that's the molar mass of hydrogen, plus 4 times 16.00, which is the molar mass of oxygen. And I end up with 180.17 grams per mole. Grams per mole will be the units for molar mass. Now for this first problem, a typical aspirin tablet contains 500 milligrams of aspirin. How many moles of this aspirin and how many molecules of this aspirin are in the tablet? This two-part problem, I'm going to kind of break it apart, but I'm going to start with my 500 milligrams, and I'm just going to abbreviate this whole compound ASP for aspirin. So it gave me that I have 500 milligrams of aspirin, and it was looking for moles of aspirin. So I'm going to write down what I'm looking for on the right. This again is going to be my direction or my guide. Now, the periodic table does not list milligrams. It's always in grams, so we're going to have to use some of our Unit 1 information. And remember that 1,000 milligrams are in 1 gram of anything. I put milligrams on bottom, so I cancel my units. And now I'm set up to use my mole conversions. Now, if we know that 180.17 grams of aspirin are in 1 mole of aspirin, and I want my grams unit to cancel, let's put that 180.17 on bottom and 1 mole on top. The periodic table is always equal to 1 mole. Now, on my calculator, I'm going to take 500, divide it by 1,000, and then divide it by 180.17. I'm going to look again at my 500 dot and remember that that's 3 sig figs, and then I get 0.00278 moles of aspirin and 500 milligrams of aspirin. Now, since this was a two-part problem here, I'm just going to keep going here. And it was also asking for how many molecules of acetyl salicylic acid are in that tablet. Now, here's where we need to think about this Avogadro's number. And 1 mole of anything is going to be 6.02 times 10 to the 23rd. Now, what are we answering here? We need to think about what is this substance. Is it made of atoms or is it made of molecules? Since I see subscripts here in different elements, that would be molecules. So for this time, we're going to put molecules on top. Moles will cancel. And then we multiply this by 6.02 times 10 to the 23rd, and we end up with 1.67 times 10 to the 21 molecules. Okay, let's continue. What is the mass in grams of one of these molecules of aspirin? So we are given information that we have 1 molecule, and we're asked for grams. So we have 1 molecule of aspirin, starting information, and we have grams of aspirin as our destination. Now here we are going to say that 1 molecule, there are 6.02 times 10 to the 23rd molecules of aspirin and 1 mole of aspirin. And then we're going to keep going because we're looking for grams. We know that 1 mole of aspirin is 180.17 grams of aspirin. So again, we're going to take 1, we're going to divide it by 6.02 times 10 to the 23rd, and then we're going to multiply it by 180.17. And then for this one, we end up with 2.99 times 10 to the negative 22nd grams of aspirin. So we see that we get this tiny little number, but that would make sense because the mass of one of these molecules is going to be pretty tiny. Okay, for this last question, how many atoms of oxygen are in that 500 milligram tablet? Now this is where it's going to really require us to understand the difference between atoms and molecules. Now let's go back to question B there, because that contains our starting information. So we know that we have 1.67 times 10 to the 21st molecules in that 500 milligram tablet. And it wants to know how many atoms of just oxygen are there. So I'm going to go ahead and look at that compound again and notice that for every one molecule of aspirin, I have 4 atoms of oxygen. So this is all we really need to do to get from molecules of aspirin into atoms of oxygen. So we're just going to do 4 times 1.67 times 10 to the 21st, and we're going to end up with 6.68 times 10 to the 21st atoms of oxygen in that 500 milligram tablet. Okay, let's check out question 2. Chloral hydrate is a drug formerly used as a sedative and hypnotic. It's the compound used to make those Mickey fins in the detective stories. Calculate the molar mass of chloral hydrate. So again, I'm going to look at my number of atoms or ions in this compound or formula unit, and I have 2 carbons, so I'm going to do 2 times 12.02. I have 3 hydrogens, so I'm going to do 3 times 1.01. I have 1 chlorine, so I'm going to add 35.45 to the mix, and I have 2 oxygens, so 2 times 16. So for this one, we end up with 94.50 grams per 1 mole of this compound. Now for this question B, how many moles of this chloral hydrate, so I'm going to go moles, and I'm just going to abbreviate chloral hydrate here, are in a 500 gram sample of chloral hydrate. So we're going from grams to moles, so that tells me that I want to cancel out the grams unit. So I'm going to put 94.50 grams of chloral hydrate on bottom, and that's always equal to 1 mole of the substance. So the grams unit will cancel. I have moles on top. It looks like this is just a one-step problem where we're going to divide 500 grams by 94.50, and we get 5.291 moles of chloral hydrate. And I'm going to try and have 4 sig figs in my answer because I have 4 sig figs in my starting information. For 2B, how many hydrogen atoms are in a 5 gram sample of chloral hydrate? So let's write 5 grams of chloral hydrate on the left. Let's be very careful. We're not going to molecules. We're going to atoms of hydrogen here. So I'm going to write down atoms of hydrogen all the way over here on my right. Starting out, we need to get rid of this grams. So again, we know that 94.50 grams of chloral hydrate are in 1 mole of chloral hydrate. Next, 1 mole of chloral hydrate would be 6.02 times 10 to the 23rd. And now, are we writing atoms or molecules here? We need to go and look at this. Chloral hydrate is made up of molecules, not individual atoms. So this word here must be molecule. Okay, now we're trying to go from molecules of chloral hydrate to atoms of hydrogen. And this is where we need to go and inspect that formula a little more closely and notice that there are 3 atoms of hydrogen for every one of these molecules. So 1 molecule of chloral hydrate has 3 atoms of hydrogen in it. So our setup is done because our unit on top matches what we're looking for. So on my calculator, I would do 5 grams divided by 94.5, multiply that by 6.02 times 10 to the 23rd, and then multiply that by 3. And we end up with 9.6 times 10 to the 22 atoms of hydrogen. Okay, I hope this helped, and if you want any more practice to check 3 and 4, just come in and see me.